In this video, we will take a look at an example of using these commands we've talked about to deal with processes, and we'll also look at the kill command. We're going to do something interesting here just to give us something more to look at because the system is mostly idle. I have a script called cpuhog.sh, and this is available in your working files directory. When you copy it to your system, you might see something like this when you try to run it. We should put the / in front of it because the current directory may or may not be in your path. So it's easier to just put the /. But you try to run it. If you get permission denied, all you need to type is chmod +x cpuhog.sh. We will cover in another video what that means and what we actually just did there. We're not quite there yet. For now, you can just type that and that should make the script work. So if I type cpuhog.sh, this process goes away and starts doing something and then immediately comes back. In fact, what it's doing is it's just adding 1 and 3 in an infinite loop. So it's just going along and basically uselessly doing an addition, doing nothing with the result. It's just a script, so we can actually take a look at the script. And there you go. It's a loop. It is doing the addition of 1 plus 3. The while colon basically makes it an infinite loop. And it puts itself into the background, which basically means it's running without us having to deal with it. So now if I do top, you'll see my CPU hog is taking up CPU. It's hogging the CPU. You'll also see that my load average on the top line is climbing up. If we were to sit here and wait long enough for that, we would get to a load average of about 2. Let me start another CPU hog. Actually, let's make it 3. Let's just go for it. Starting up 3 CPU hogs. We'll go back to top. So now you see, if you look at my display, my idle time on that third line is now 0. There is no idle time happening on this system. I am completely using up the CPU. My load average is now over 1. So things are just starting to bog down. Eventually, all 3 of my load averages, the one that's up 1.7 now, if I waited long enough, the 15-minute average is obviously going to take longer to get there. These should all end up being at around 3 if we go long enough. We're going to quit again out of the top, and you'll notice I don't have any indication whatsoever that I have these processes going, that all my CPU is being used up. This is where some of those commands are useful. If I feel like things are getting slow, I could do uptime. I could see my load average. Oh my goodness, something is wrong. What is sitting here running and using up CPU now? I see that load average and that tells me that things are busy. I can do top and I can see what is it that's making it busy. Oh, it's this CPU hog. So now what can I do with it? Well, we have a command for just this situation and it's called kill. So if I just type kill, I get an error message that tells me you need to give me some more information. And it's a very terse error message. Generally, the convention is things that are in square brackets are optional. Things that aren't in square brackets are required. So you see I have a required of a PID. That's the same PID we saw in the PS output and that we see in the first column in top. So I need to know the process ID, the PID of the process I want to kill. So if I do a PS, I can see these guys are in here. And I can see that the first one is process ID 6624. So I can say kill 6624. Now if I do PS again, you see that one went away. I have killed that process. So let's just do that with the remaining 2. 7346 and kill 10883. Then if I do a PS, do an uptime, things are coming down. Put a top there for a second, and we can just watch. The load average should start coming down. You see our 5-minute average, our 1-minute average is starting to come down now. Our 5-minute average, the second number, had gone up a little bit. It's going to start coming down a little bit. It moves a little less quickly. And the 15, of course, moves the least quickly of them all. Something you may have noticed about my kill commands, I didn't get any interactive feedback whatsoever. Let's start up CPU hog again. If I do a PS, I type kill 5507 and I hit return. Nothing happens. Nothing tells me that it's killing the process. Nothing tells me that it did find a process with that ID. Nothing tells me really anything. And this is a general tendency in Linux. Linux assumes if you typed it, you knew what you were doing. If you typed kill this number, you meant kill this number. So it's not going to sit there and annoy you and ask, now did you really mean you wanted to kill this? No. You typed it, you meant to kill this process. So Linux goes ahead and does it. It's a little bit of a misnomer to say that kill kills processes, because that's not actually what happens. Actually, what it does is it sends a message to a process. And the default message of the kill command is the message, you need to quit now. Most processes do behave and they do that, and the mechanics of what's actually happening and what those messages mean and how processes work, that's more of a Linux internals kind of thing and definitely beyond the scope of this video and this course. But there is one situation that we need to cover, and it's important to know that when you kill a process, it doesn't really die. It gets told to quit. If for some reason the process doesn't listen to that instruction or it can't listen to that instruction, then the process is not going to die when you send it a kill. There's two fairly common situations that cause that. The first is if a process is waiting for something, usually waiting for some I/O, and if that I/O isn't happening, you're waiting for something to come in from the network and the remote site you're talking to isn't communicating. And so the process is sitting there, it's waiting for the input, and it's not getting the input. While it's waiting for the input, it's not doing anything else, and so it also cannot respond to the instruction to quit. That happens sometimes. The second thing that can happen is called a zombie process. Now, you got to love that name, right? A zombie process. That is actually what they are called, is zombie processes. In fact, go back to top. When we did top, if we look on that second line, it tells me there are 132 total processes. 2 are running, 132 are sleeping, 0 are stopped, and 0 are zombie. It's an official thing. There are real zombies in Linux. So I have a program here. This one's not in your files. This is just a little program I have here for demonstration. What this guy does is creates a zombie process, just so we can see what one looks like. If I go back to top, I now have one zombie process. What's a zombie process look like in PS? It's this one called zombie, and it has this little defunct by it. The reason it's called a zombie process, and it's actually a very good name, a zombie process is dead, but a remnant of it has stuck around and continues to live on. So it's called a zombie. It's dead, and in fact, you cannot kill a zombie process. Why can't you kill it? Because it's already dead. 200958. I can do that. I can do PS again. I have not affected the process whatsoever. By definition, what a zombie process is, when a process in Linux ends, it always has that parent process that we looked at in PS, and there's a little bit of cleanup the parent process has to do. So if the parent process isn't doing that cleanup, that's what gives you a zombie process. And that's essentially all that little program I ran does. It creates a process, it creates a child process, and then the parent process ignores the child. So we cannot kill the child. The child exits and finishes, but the parent is not paying any attention to that, and so we create a zombie. So the fix for a zombie is to figure out what the parent is. In this case, we know. And if you kill the parent of a zombie process, 20957, if you kill that, now I get told that my zombie is done. And if I do a PS, no more zombies. So that's just a little thing to keep in mind. Because kill sends a message to a process, it does not actually kill a process. There are a couple of situations where a process can't be killed.